The popularity of egocentric videos is growing faster than ever. Users produce and share long streams of video which are usually tedious to watch. Sampling at a fixed rate is a naive approach to speed up such videos. However, it amplifies the video shakiness introduced by natural body movements, causing visual discomfort. Hyperlapse techniques perform remarkably in this context, producing smooth fast-forward videos. Despite that, the semantic content of each frame is neglected, considering all frames equally relevant to the user. In this work, we face the challenge of producing hyperlapse videos with more semantic content. We start our methodology with an egocentric video as input. The very first step is a frame-wise processing. We analyze the semantic information using a classifier trained from the preference of the users. The classifier assigns a semantic score for the frame. The same process is performed for all frames, creating a semantic profile of the video. From a threshold value set using the Otsu method, we separate the video into semantic and non-semantic segments. Using the length of the segments, we define different speed-up rates for each type, emphasizing the semantic ones by a lower rate while keeping the whole video in the desired speed-up. However, notice the blue area of the semantic plot. Some portions of the semantic segment are even more relevant. Therefore, we calculate new threshold values and refine the semantic segments iteratively. The portions with the highest semantic content become even more emphasized, establishing a multi-importance fast-forward approach. Then, we create a graph for each segment, where every frame in the input video becomes a node, and the edge weights are a linear combination of the shakiness, speed of motion, visual appearance, and semantic information related to the frame transitions. In order to achieve the desired speed up, we multiply this linear combination by a transition skip factor. At this point, the user has many parameters to set. To remove the user from the pipeline, making our methodology fully automatic, we use the bio-inspired algorithm particle swarm optimization. Given the speedups and the graph weights, we run a shortest path algorithm to select the best frame transitions. For every node not included in the shortest path, its corresponding frame is excluded from the final video. The side effect of emphasizing the semantic segments is increasing the speedup rate of the non-semantic segments to control the speedup rate of the final video. It causes the non-semantic segments to be jerky. To overcome this issue, we propose an egocentric fast-forward video stabilizer. The fast-forward video and the dropped frames are now the input to the stabilization process. We started by segmenting the video into portions of length alpha and selecting the most representative frames of each segment, the master frames. All frames between two master frames are smoothed by a weighted homography transformation. Once the frame is distorted by a perspective transformation, black areas may be generated in the image. In this case, we reconstruct these areas, performing a stitching process with the dropped frames. Finally, we crop the reconstructed frames and create the final hyperlapse video.